Now we have Mary Kate Dwyer from Biomedical Engineering will present treating traumatic brain injury with synthetic hormones.
So growing up, I think started playing soccer when I was about 5 years old. And one thing I really remember is that my mom would not allow me to head the soccer ball. Not in practice, not for a game. It was absolutely too dangerous for her. And in retrospect, she was right. And so now what I'm studying is traumatic brain injuries. This example I have here on the screen is from a recent Women's World Cup game where two players went for a header, ended up colliding heads. Both had to be helped off the field, and actually the American on the right wasn't able to return in the second half. And so, especially in sports, we're discussing concussions and more severe traumatic brain injuries more and more often, which is a great thing, but these injuries are clearly still occurring. So my research kind of focuses on how can we help these people after an injury. We're doing that by finding drugs that can actually treat the traumatic brain injury, which is super important because there are actually no clinically approved drugs to treat TBI right now. So specifically, my work uses a novel hormone. This novel hormone is synthetic, meaning that it was designed in a lab, and it actually has slightly different effects than a naturally occurring hormone that we might have in our bodies. And so the way that we test this drug is we actually take slices of a rat brain and we remove them from the rat body and we keep them alive outside of the body for several weeks. We then induce a brain injury on these brain slices that we keep alive. And we do this with a very sophisticated thought-through protocol to really mimic what's happening in the brain as it's protected from the skull, but as the impact's coming in. But at the same time, in practice, what this really looks like is that we physically stretch the slices to a predetermined length. And so after we stretch these slices, we see the same problems in our brain slices that we would see in a normal traumatic brain injury. We have cell death, we have inflammation, and we have dysfunction in the neurons where they can't really communicate properly. And the great thing is that when we apply this novel hormone just an hour after injury, we can decrease all of these bad outcomes. So this is great because I think that thus far my work has kind of presented a possible new therapeutic to help human health. It's definitely a stepping stone, and the future work will involve characterizing it in live animals and in humans, but I do hope that this drug can be used to improve human health after traumatic brain injuries. Thanks.